Hello, Algebra 2 students. Today we will be doing 6.6 notes, solve radical equations. This might be your most favorite section of chapter 6. A radical equation is an equation with one or more radicals that have variables in their radicand. There are 4 steps to solving radical equations. Please follow the steps in order. Step number 1, isolate or get that radical by itself on one side of the equation if you must. If it's already on one side, then you don't have to do step 1. Step 2, raise each side of the equation to the same power to eliminate the radical. So step 2 is crucial. Honestly, all the steps are important. Step 3, go ahead and solve the equation for your variable. And step 4, check for extraneous solutions. You really want to check for extraneous. Remember, extraneous is a false solution. You end up getting an answer which then will not check. So you want to do this when you have 2 answers. And so let's go ahead and begin and do example number 1. So in example number 1, and we'll start with a little easier and then work our way into more difficult questions. So in problem number 1, notice the radical is already on the left by itself. The x plus 6 is in the radical. And so you don't need to do step 1. Step 2, you raise each side of the equation to the same power. Well, notice that's the square root of x plus 6. So you are going to square both sides. If it was a cube root, you would take each side to the third power. And so when you square the left side, you're just left with the contents inside the radical. And the right side, 3 times 3 is 9. Subtract 6. X equals 3. Let's check. So always check back into the original equation. So we are going to replace x with 3 plus 6 equals 3. Now the 3 plus 6 are inside a radical, so keep them there until you're ready to take the square root. The square root of 9 is 3. When we're checking, you don't worry about the negative number. That's when you only have a variable. So 3 equals 3, and it checks. Therefore, this is our solution, x equals 3. Okay, next we're going to do problem number 2. Now, problem number 2, you're thinking, or you should be thinking, I don't see a radical. I just see a fraction exponent. But remember, you can go from a fraction exponent and write it as a radical. We will do that later. But whenever you have a problem like this, where you have something raised to the 2/3 power, in order to eliminate it, you want to multiply both sides by the reciprocal of that power. So it'd be to the 3/2, and then do 16 to the 3/2. And that's what you do for that particular one. And so the left side, the 2/3 times 3/2, that cancels into 1. So you're just left with 3x plus 4. And the right side, I'm going to write it as a radical. So remember, your base is 16. Put that in the radical. The bottom number, your index, that goes here. And then put it in parentheses. The top number of your fraction is always that power that it's raised to. And now we can proceed with solving the equation. So you have 3x plus 4. The square root of 16 can be a positive or negative 4. So I will put plus or minus 4 raised to the 3rd power. So we have 3x plus 4 equals 64. And 3x plus 4 equals negative 64, because negative 4 times negative 4 times negative 4 is negative 64. Subtract 4 on both sides. 3x equals 20. Divide by 3. 3x equals 60. Divide by 3. X equals 20. Don't circle your answers until you actually check them. Especially, like I said, for the number 1, we didn't really have to check. We knew we only had one answer. But on problem 2, we're going to have 2 answers. So we have 3x equals negative 68. Divide by 3. Never change your answer into a decimal unless you have a real life problem. So that would be x equals negative 68 over 3. Now we are going to check each one. So let's check the x equals 20 down here. I believe I will have room. Don't write too big, and hopefully you have room. And if not, you can use the space where the solving radical equation steps are. So where do we check it? We check it back into the original problem. So 3 times 20 is, I'm going to take a shortcut there, is 60 plus 4 to the 2/3. Does it equal 16? So that's 64 to the 2/3. Does it equal 16? So write 64 as a base. You take the cube root of it, and then you square it. Does it equal 16? Well, the cube root of 64 is 4, and 4 squared is 16, so that does check. Sorry, I had to write so small. And let's check the other one right over here. So check x equals negative 68 over 3. Give myself a little bit more room. So I am going to replace, so 3 times negative 68 thirds plus 4 to the 2/3. Does it equal 16? Well, here, look, the 3's cancel, so you're left with negative 68 plus 4, which is negative 64. And then negative 64 is your base in the radical. 3 is your index, so you're taking the cube root of it, and then you're squaring the answer. So cube root of negative 64 is negative 4, and then that's in parentheses, it's squared. Negative times a negative is a positive, so they both check. So you have two answers here. We have x equals 20 and x equals negative 68 thirds. So both of them are solutions. Okay, now let's do example number 3. So example number 3, the radical is already on one side, and so we can go ahead and skip step 1. Step 2, because the radical is under a square root, we want to square both sides. And remember, x minus 2 squared just means x minus 2 times x minus 2, so we will use FOIL here shortly. And the right side, the radical squared is just x plus 10. Easy enough. And so we want to use FOIL on the left side. Remember, first, outer, inner, last. First times first, x times x is x squared. Here's my outers. There's my inners. And my last numbers are negative 2 times negative 2. There, easy enough. Okay, now we want to get one side of our equation equal to 0. And obviously that's going to be the right side. So let's combine like terms here. So we have x squared minus 4x plus 4 equals x plus 10. Then we want to subtract x, line it underneath here, subtract 10, and line it underneath there. So we have x squared minus 5x minus 6 equals 0. Once you get one side equal to 0, because this is a quadratic, since x is to the second power, our options are to try and factor it, to use completing the square, which you don't want to use because the middle term is an odd number, it's 5, or our last resort, use the quadratic formula, which most people don't want to do. So you first start with trying to factor. So remember, when we factor, we need to identify a is 1, b is negative 5, and c is negative 6. And make your little factor chart here. So we don't want to write too big because we need to check this. So you know what? I'll put my factor chart right here. B is the bottom number, B for bottom. So put negative 5 here. A times C goes up in the top. So A is 1, C is negative 6. So multiply them, you get negative 6. And then you need to solve the x puzzle. So what two numbers multiplied together give you negative 6, but added give you negative 5, and they have to be the exact same two numbers. So it might take you a little while to think of those two numbers, but I thought of them right away. It'd be 1 and negative 6. because 1 times negative 6 is negative 6. 1 plus negative 6 is negative 5. And so they go in your puzzle, or they solve the puzzle, and then you can write those as your factors. So put your variable first in each parentheses, and then it doesn't matter which order you put them in. So x plus 1, x minus 6. And now you're finally ready to use the zero product property. Set this equal to 0, set that equal to 0, and you will have your two answers. X plus 1 equals 0, or x minus 6 equals 0. Here, subtract 1 on both sides, you get x equals negative 1. Add 6, x equals 6. Of course, we don't check them, or we don't box them up until we check them. So I'm going to go over here, and I will check each answer. I'll start with checking x equals negative 1. So replace negative 1 on the left and negative 1 for the right side. That's negative 3. Negative 1 plus 9, negative 1 plus 10 is 9. And when you're just checking, you're only taking the positive square root. So the square root of 9 is 3. You're not interested in putting the plus or minus. So this doesn't check. Negative 3 is not equal to 3. So this is an extraneous solution. Let's check the other one. So 6 minus 2 equals the square root of 6 plus 10. 6 minus 2 is 4. 6 plus 10 is 16. Take the square root of the right side, and it does check. This is our one solution. So x equals 6 is a solution, but x equals negative 1 is an extraneous solution. Okay, now we'll do example 4. Example 4, notice you have a bunch of stuff that's with the radical. So you need to get the radical by itself. The first thing you want to do is move over the negative 7. So add 7 to both sides. You have this 3 out front. Next thing you want to do is divide both sides by that coefficient in front of the radical. The 3's cancel. So you're left with cube root of 16x. 24 divided by 3 is 8. Now, what you want to do is, because there's a cube root on the left side, you want to raise each side to the third power. Right? And so we just want the contents inside. 8 times 8 times 8 happens to be 512. Use a calculator if you need to. Divide by 16. I would. If I'm going to use it, I expect that you would want to use it also. I'm not going to sit here and divide 512 by 16 long ways when you can use a calculator. It does divide nicely, evenly. X equals 32. Let's check. 3 times the cube root, I don't even have to put that, of 16 times 32 minus 7, does it equal 17? So 3 times the cube root of 512 minus 7, does it equal 17? So we know the cube root of 512 was 8. So we have 24 minus 7 equals 17. Now, do you have to check every problem? Not if you're very careful and you do your work very nicely, but you must check the ones with 2 solutions. You just must, because you don't know which one's going to be extraneous and which one's going to be the actual solution, or if both of them will be solutions. Let's do number 5. And number 5, we won't check, or number 6, if there's only one answer. So let's just do our work really, really carefully. Number 5 can scare people away because you have 2 radicals. That's okay. You want a radical on each side. So I would move the one that you have to add to the other side. So you don't ever want to subtract. So add this one. This one's not that bad, actually, once you get over the fear that there's 2 radicals. So on the left side, you have cube root of 12x minus 5. And on the right side, you have cube root of 8x minus 15. And hopefully you know, since it's cube root, we want to raise both sides to the third power. It's really not bad. Pretty easy, actually. And then the cube root of the left side is just 12x minus 5. And the cube root of the right side is just 8x minus 15. And now this is a simple equation. We have variables on both sides. So you want to get x's on one side. So let's subtract 8x. And then you want to add 5 to both sides. And then divide by 4. X equals negative 5 over 2. We always want to simplify our answer. So always reduce your fraction. And this does check beautifully, but we're not going to check it because I feel like we've checked enough. So let's do our last problem. Now the last problem is one I believe I put on the test. So most students want to try and multiply 1/4 times everything. You can't do that, first of all, due to this. But you do want to get all that stuff by itself. So the first thing you want to do is multiply by the reciprocal of 1/4 to get rid of the fraction. So multiply both sides by 4. And that cancels, and you're left with 7x plus 8 to the 3/2 power equals 54 times 4 happens to be 216. And then what you want to do is you want to raise all of this to the 2/3 power, because that'll get rid of those exponents. Because the 3's cancel, the 2's cancel, and you're just left with 7x plus 8. And you're happy, extremely happy. And on the right side, we want to write that as a radical. So put 216 as your base, put the bottom number as your crease, and then put this in parentheses and square it. So we have 7x plus 8. Cube root of 216. What number multiplied by itself 3 times gives you 216? So I said memorize them or make sure you know how to use cube root function on a calculator. So this is 6. 6 times 6 times 6 is 216. And then you're going to square it. 7x plus 8 equals 36. Now it's your mistake if you called 6 squared 12. So you have to be really careful and really check what you're doing. Subtract 8 on both sides. 7x equals 28. Divide by 7. X equals 4. And it does check beautifully, and we're not going to check it just because, like I said, I think we've checked enough. And those are your notes for today. Have a great day, Algebra 2 students.